Okay, so we have two theorems that we're going to talk about today, and that is the triangle sum theorem and the exterior angle theorem. The triangle sum theorem just means that all of the interior angles of any triangle has to equal 180 degrees. So I know that if I have some triangle, and this is 90, for example, then if this is 67, I would grab my calculator, if I can find it, grab my calculator, and I would do 180, because I know it's what it has to equal, minus the 90, minus the 67, gives me 23. So this missing angle is 23 degrees. We'll learn some other shortcuts having to do with the right angle later on. The exterior angle theorem, if we have some triangle, okay, and there's a couple different ways of looking at this. So if this is 40 and this is 85, okay? If I'm looking at it in relation to this angle right here, this is called the exterior angle. And then in relation to this one, these two are called the remote interior angles. Okay? And the exterior angle equals the sum of the two remote interior angles. Okay, and the reason is because the sum of this triangle equals 180 degrees, and these form a linear pair, which means they have to also equal 180 degrees. So if I have 85 plus 40, that gives me 125. Subtract that from 180. Or you can look at as this angle, this exterior angle, equals the sum of these. So this angle here has to equal 125. These then are supplementary, so that gives me 55. So 85 plus 40 plus the 55 better equal 180, as well as the 55 plus the 125 also equals 180. So I have some examples that are already written out, save a little bit of time. So feel free to pause for each example to write down the problem in the diagram. So in example 1, we are finding the measure of angle A. So I have all of this algebra stuff, okay? I know that the measure of all three angles has to equal 180 degrees. So I'm going to write an equation of angle A, which is x plus 55, plus angle F, which is x plus 61, plus angle D, which is 80, has to equal 180 degrees. So I'm going to combine like terms. That gives me 2x, 55 plus 61 plus 80. I'm going to go ahead and add that. And I get 196. Has to equal 180. Subtract 196 on both sides. And get 2x equals negative 16. So x equals negative 8. Now, be careful with this, because my first response was, well, x can't be negative. I cannot have a negative angle. But if you look, x isn't an angle. So negative 8 plus 55 is going to give me the measure of angle A. Negative 8 plus the 55. So angle A actually gives me 47, which is what I'm asked to find. And then negative 8 plus 61 gives me 53. I wasn't asked to find it, but I like to be able to check my work. So I know that these three angles better add up to 180. Well, there's 80, so these two better add up to 100, and they do. So I know my answer of x equals negative 8 is correct, and then plugging it back in and getting 47 is correct. Again, pause it so you can write down the diagram. So I'm looking for angle R. So this looks kind of like a puzzle. You're going to see an awful lot of this figure. We call that the bow tie, because when you have a bow tie looking figure, we know that we are going to have vertical angles. That's the first thing I do whenever I see a bow tie figure. So 55 plus 66. These two have to add up to 121. So then I know that this one has to be whatever 180 minus the 121 is, which gives me 59. These are vertical, so that means this also has to equal 59. And then I know that these angles in this triangle has to equal 180. So 180 minus the 59 minus the 33, and that gives me 88. So don't think that what we are doing right now has anything to do with congruent triangles, because it doesn't. We are just looking and using the triangle sum theorem. Okay, so angle R is 88. So making sure that we actually answer the question. Okay, last two examples. Again, pause it so that you can draw the diagram. So this is using the exterior angle theorem, and I know that angle E plus angle F is going to equal this exterior angle. So 6x plus 15 plus the 40 needs to equal this exterior angle of 10x plus 15. Combine some like terms. 6x plus 55 equals 10x plus 15. I'm going to subtract 6x from both sides, which gives me 55 equals 4x plus 15. Subtract 15 on both sides, I get 40 equals 4x. Therefore, x equals 10. And that's what I'm asked to find. I am going to double check my work to make sure that they do actually equal each other. If I put a 10 in here, that gives me 60, plus that gives me 75. So this better equal 115 when I look at those. 10 times 10 gives me 100, plus the 15 does give me 115. I could go one more step and find the missing angle here, either because these are supplementary or because I have a 75 and a 40. So I have enough to find out that this is going to be 180 minus the 115 gives me 65. Okay, so another way of doing that problem, or adding stuff on that problem. Example 4, again, go ahead and pause it so you can draw the diagram. On this one, we are looking for x, y, and z. So the first thing I always like looking for is the obvious, meaning usually the obvious to look for is if you have two of the three measures of a triangle, then you have enough information to find the third one. So those two together give me 110, which leaves 180 minus 110. So that means that this is going to be 70. That's really terrible there. 70. Then going back to what we've already studied, this plus that has to equal 180. So I know that 70 plus 65 is 135, which gives me 45. And then we are right back to You have two angles of a triangle, which means I have enough to find the third one. So I have 180 minus the 45 minus the 31 makes this angle 104. So we can check this. These also give me 135. The remote exterior would be 70 plus 65, which is also 135. So there are checks everywhere when you are working with triangles. So X is 70, Y is 45, and Z is 104.